Hello and welcome to today's webinar presented by Dlubal Software. Today we'll be working in our Finite Element Analysis and Design software, RFEM. The title for today's webinar is RFEM Webinar 3, Integration with BIM Workflows. This is the third and final webinar of a three-part series geared to giving users an insight to RFEM, starting with the more basic features, moving on to the advanced, and finally ending with BIM integration. My colleague Walter Ressler will be your presenter today. He's the Sales Director and Customer Support Engineer, and he is located in Tiefenbach, Germany. My name is Amy Heilig. I'll be your moderator, answering any questions you may have. I'm the CEO of the U.S. office. I'm also a technical support and sales engineer, and we are located in Philadelphia, Pennsylvania. If the control panel does seem to get in your way of the presentation when you logged into the GoToMeeting, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the webinar. You can use this same dialog box to do so. If by chance we don't get to all the questions, I'll certainly send you a follow-up email afterwards. And with that said, I will turn it over to my colleague, Walter.
Okay, thanks Amy for the introduction. Hello from my end too, and the next close to an hour I'll talk about the BIM integration of RFEM with other various CAD applications such as Revit, but also Tekla, and if we got time also a little bit about Bentley, the ISM interface. Before we step into the software, I'd like to talk a little bit about the differences between the file-based exchange and the direct links, and I want to explain a little bit of background information about the physical and the analytical model. Then we'll dip into exchange scenarios, show the round-trip design, and during this I'm sure you will get a lot of tips and tricks how to exchange data with Dlubal RFEM. The file-based exchange is also same as the direct interfaces come all with RFEM automatically. When we use a file-based exchange, however, we have to translate more or less the data that we have in RFEM or in the CAD software into a standardized format. Depending on the specification, what entities and what kind of objects these formats provide, we may or may not be able to write our data into these files. IFC, for example, has no way to write for us, for example, nonlinear supports or information about load generation standards, a lot of information we just have in our software. So if this specification or the standard format does not provide a container for it, it's hard for us to write it there. On the other hand, it's an easy thing because we can just write a text file. It does not require any installed applications. It's a non-proprietary format. That means it should more or less work with all other applications. As good or not good, they can read and write those formats. And disadvantage is that applications do not really talk directly to each other. Typical candidates for DXF, for text file-based exchange is DXF or IFC, and if you go to file export in our software, you find all those formats that we support, such as SIS2, Sdnf, or newly we implemented also the direct export of a advanced steel file SMLX. So if you use that software, there are some new options. Okay, the direct interfaces, on the other hand, avoid all these complications. We can look what does the other software provide, which objects are there, can we use it, can we directly address it. So we talk to this other software using the so-called APIs, application programming interfaces. and we link those programs directly. So we don't have to go through a like format specification, and we can just get and read and write what we find in the corresponding applications. However, this technology requires a direct installed application. That means both applications have to be on the same computer, and I would like to highlight that we don't need a license necessarily a license for all of those software. For example, in our case, we can install a trial license which runs out and gets into a demo license, but we still can use it to write a file from our direct interfaces and store it as a RFEM file, and then this RFEM file can be given to a structural engineer that has a full version to work with it. So the big advantage is we are much more free what we can do, what we can write. We can link really live the applications seamlessly directly to each other. Yeah? So direct interfaces we have currently to Tekla structures, to Revit structures. Those are the most important applications with direct interfaces. Okay, then, yeah, next topic I'd like to explain is the difference between the physical and the analytical model. We have to understand these are two different models, and when I look at the pictures on the right side, there is a steel connection, and this is you can say this is a physical model. There's bolts, end plates, cross sections, haunch section stiffeners. But how do I put in my structural lines in there, my center lines, my model, my stick model that I would typically make in a structural software for this? It can be done maybe this way. So we have 1, 2, 3, 4, 5, 6 members, 4 nodes, or it can be done maybe with a numerical transformation of the eccentricity. So some software has eccentric links that can be used, and they don't need actually a separate member to connect those gaps here. Or in a simplified model, we can have just ignore this eccentric haunch here and just have a straight member. So there's different ways how we can do it, and obviously it needs a little bit of the help of the engineer to decide how they want to build that model. And the second thing is typically when we have in a CAD application or in a BIM software, we have a volumetric view, and it means that either boundary surfaces define a solid, and we get the real geometry of this structure, while in an analytical software, we typically would describe this beam as with a node of beginning, node ending, and with a cross section that define the stiffness and also the resistance of this structure. You know, what we see below here is what we would also get in the so-called IFC coordination view. So we get a volumetric model, and this above would be the IFC structural analysis view. And these are two different models, and not necessarily IFC takes care of the transition from one model to the other one. So this has to be done either in the BIM software or then afterwards in the structural analysis software. Another variant of the solid can be a so-called swept solid, where we start with a section area that is extruded along a line which defines then the longitudinal extension of a member, which helps us if we have this swept solid representation, because we can automatically or more or less automatically find out where is beginning and ending, and if we have a little bit information about the cross section, we can import this more or less seamlessly. Yeah, and with this we would step right into the a live demonstration. I will then go open the software and explain a little bit what are the different scenarios, and I will also explain the analytical models in the different software that we look at today. Okay, let me see. I start with Autodesk Revit 2018, which is the current version of Autodesk. So that has been just released in May. So we updated our interface. We are part of the Autodesk Developer Network for many years. And we typically get those pre-release versions so we can build the interface even before there's an official release, and we can test it out. And once the full releases are there, we can then provide interfaces in short time. I have a variety of models I would like to show today, and I start with a quite simple one, which is called OS Webinar BIM Simple, because I think it easily allows us to understand how these procedures work and what's in those Revit models, and also then later in the Tekla models. What we see here is the physical model, so it's the real model that you would build, and beside this there is also the analytical model that can be shown inside Revit structure or Revit, this model is more or less built with the help of the software, and the user can modify it and apply it as he likes it and change the geometry of this model. For example, if you look at this beam, in this beam you can enable or disable the analytical model. If you do so, then the analytical model disappears. It's gone, the node is gone. And if I enable it again, it will be created and it inserts the stick model. I can also influence where this stick model will be placed. When I click on this member, I can look at the analytical beam properties, and here I can influence the analytical alignment. Now it's set to auto detect, but I can also say project or into projection, and then at the start and at the end I can bind it to the center of the element. You can see how this line moves down, and if I do this at the other end, then you can see also the node here is created and it moves downward. You have also a analyze menu here where it gives more options. For example, you have the option to adjust the nodes. When you click there, you can see you have drag and drop options. You can insert analytical links. You can adjust walls. There are some ways how to model this analytical model inside Autodesk Revit. Next to this, there is a certain type of boundary conditions, fixed, pinned, roller, user, and they are also displayed here in this model. We have loads, load cases, load combinations. There are some possibilities like with line and area loads, hosted point loads, hosted line loads, but it's for our feeling, what we are used to have in RFEM, it's much less than what RFEM would offer. So for you, you have to decide yourself where you enter your loads, whether you do this in Revit or where you do this then in RFEM, where you have all these tools to generate loads and to create load combinations. In this model, we have 5 load cases altogether. We have no load combinations. It's kind of basic here how you can enter and create those combinations. I would like to do this in RFEM. If I want to make combinations in RFEM, I think it's much more easy. We'll see this later. Okay, Let's see what happens when we start the interface to RFEM. So we have a couple of linear loads, couple of nodal loads, we have the analytical model, we have supports. In some of the analytical model, like here on this diagonal, we have also additional parameters. Here it said member type tension. This parameter is a user-defined parameter that we created in our interface. When we install RFEM on top of Revit, then the interface will be automatically installed and you have it available for use. So this comes with RFEM at no extra cost. Every RFEM user has it. The interface is controlled by 3 buttons mainly: export, import, calculation, import, which is like a start of a workflow where we export the model, run the calculation and import some results. Also we have the Dlubal parameter. These are the parameters I was just talking about: member type tension, member type truss, and here's also a way how we can match a material databases and cross-section databases. We just assign different parameters to the materials and the cross-sections. These are text parameters that identify the different materials and sections from the library in the Dlubal software. Typically, you work with families in Revit, and if the families are not named according to the Dlubal standard, then you can match it using those parameters. And there's a couple more which I don't want to go into details now. Yeah, I have here the families loaded, pretty much all of the W sections. This I suggest that you set up in a template what you typically use and use this template, and then you have usually no problems with conversion of cross sections. And there is more parametric possibilities that can be done in cross-section mapping files, for example. Okay, but let's look at the first attempt and we'll export this model. So these 3 buttons are for RFEM and these 3 buttons are for RStop, which is the same interface. RStop is our second program that includes only members, no surfaces, no solids. It's a little bit lighter version of RFEM if you want to say so. I have RFEM open here in the background, but no model is open. Yeah? So I start the export and the dialog opens, which allows me to control certain things. I can create a new structure in RFEM, I can override an existing one, I can update an existing one. Since I have not a new one open, I create a new one. Here is the option: if I don't have any license, I can export to a file. I need an installed version, demo version, trial version, but no license. And I can create an RFEM file that I can give to an RFEM user with a full license. I can select certain objects. I don't have to export all the model. I can export just a level. I can export beam, column, whatever. I can export visible objects, and I can export only members or surfaces. I just leave out all the definition of hinges or supports in Revit, because if the Revit engineer didn't do exactly what I want him to do, then for me it's easier just to ignore everything and just get the plain geometry and I work with it in RFEM. You can do so, you don't have to. Okay, most important here is also this cross-section Dlubal parameter to use. Material name from Dlubal parameter. I have set that up. I can show later where that is. Structural analysis. We apply the structural data. We apply the loads. Self-weight we assign in the load case 1, that load. And we'll create, or if we would have some, we'll create some load combinations. Also, I can convert isolated foundations and wall foundations to simple supports. That will show also in a different example later. When I start the export, I get a little history that is written down, a little dialog. I have a log file that helps me to review what happened. I get the IDs here. I can search for IDs. and in case of problems, this is helpful for our support. Yeah? Okay, then yeah, close this. I open RFEM, and you can see RFEM has already the model open. We can see that there are the cross sections. We can see them in the table as they were assigned in Revit. Revit had this name, and the cross section here was transferred correctly into the RFEM library nomenclature. So we have the correct section here that has all the right parameters. Also here, the 1-inch cross section was transferred into a roundbar 1 by AISC. So when I look at the materials, also steel ASTM was transferred to steel, ANSI AISC material, and same to ASTM. So with this, I can, in the load case, loads are also here, I can see also here there's some hinges that have been defined, there's the supports, and also this parameter tension only was transferred also correctly to this tension bar, and the other one didn't have the parameter, so that's a beam. Yeah? So with this, I can start my analysis, just a basic load case with self-weight, and we'll see we get results, we get bending moments, we get support reactions. So without doing anything, I was able to analyze this simple model. Also, I'd like to point out that here, this column is still one part. The beam connects here along the column, but since the node is exactly on the center line, it is possible to mesh it, and it will automatically connect and get correct results. So this is something that RFEM can do, which is not so necessarily possible in other programs. What I forgot to point out, we have also so-called rigid coupling. In the Revit model, if there is some eccentricity, it's possible that we work with analytic links. You can allow or not allow analytic links. If you modify the analytical model, you can allow them here. If you do not allow them, then the analytical links disappear. If you allow them, they are built in automatically. Yeah? Good. So this is the easy part. Now, what happens if we deal with changes? When we work with changes, we can either have changes in Revit or we can have changes in RFEM. So let's start with the Revit part. For example, I'm going to copy this beam over and make a change here. For example, let's say horizontally 4 foot. Yeah? What happens? We'll automatically get a new analytical model because it's enabled. Yeah? The software automatically finds the node on the line and on the other side as well. So this doesn't look too good to me, so I'm going to change my analytical model again in Revit for this first beam, and I'll set back the start alignment and the end alignment to auto detect, and you see it is aligned on the top. Yeah. Typically, beams are placed in that way that the C justification is top. That means the insertion line is on top and the beam expands to below. Okay, so there's one change. How to get this over to RFEM? Same procedure, export model. This time I update the existing structure. And I'd like to point out the first tool here. We have to check here, update objects to partial view. So everything which is not found in the RFEM model will get assigned a certain visibility. When I start to do this, it goes quite quick, and I open RFEM, and we'll see here, it's better to see when you have the rendered view. There is 2 beams highlighted. In the views here, you see there is a visibility created that's called Revit Update with date and time. If you want to see only this, you select it here. If you want to cancel the visibility, you see everything. At any later time you want to see what happened here at that time, you'll see this. Yeah? So you have a way, some simple way how to track this. Now I'm going to do the other way. I'm going to change something in RFEM and bring it back to Revit. How to track those changes? One way could be I create a new visibility. I can do it down here. I'll group it under the other Revit update, and I can call it, for example, phase 1. Okay. And the important thing is that you check here, add new objects into visibility, phase 1. Yeah? So everything which I add now into the RFEM model will go into this visibility, and I can find it later on. Also, I can address it, and I can match my export to Revit according this visibility. So what I'm going to do is I'm going to copy this beam over here, for example, with the move copy in RFEM. Maybe, okay, half is 8 foot, let's say 4 foot. Okay, 3 copies. Okay, and we have now 3 more beams, and the new beams should be in this visibility 1. So if I check this visibility phase 1, you'll see only those beams. Huh? Okay, maybe I do another change in the loading. Okay, change the size of the loading. Yeah, and also I can create a new cross section. I want to have a smaller cross section, create a new one. It was a W14, so we'll take a W10 maybe. Yeah, okay, okay. So I made a couple of changes, and I want to update those changes. Yeah. Now I can either put all those changes, if they're not automatically in there, I can also manually influence this. I can say, okay, this change, the selected beam should be assigned into phase 1, and I say here equals, redefine. Yeah, everything selected will be added. Yeah. And now if I activate this visibility, then I have only this. Yeah? So I can now update this, either select it, create a new view in Revit, make a duplicate view. Yeah? I can rename it to anything. Update 1. Okay. And in this view, I can basically just hide everything, elements. Yeah? And if I import now, and I go back, yeah, I have it selected. If I import now into Revit my model, only selected objects, then I can apply loads, or I can not apply loads, or yes, I can apply loads. I can start the import. Revit now converts my cross sections, goes through all the loaded libraries and converts the cross section naming. And this can take a few seconds depending on how many libraries you have written, how many families you have loaded. And then you see here, my new objects are here. Yeah? Update 1. If I go back to the complete analytical model, everything is there. Yeah? So also the white flange beam is changed, and we have here now the justification is not yet set up. You can, because we don't know how you want to have it justified in Revit, we'll put it to center, but with a few clicks you can change them to top. Note that here we didn't modify it because it was modified before in Revit, so we just changed the cross section. Yeah? Okay, so this is one way how we can modify and play with the different models in Revit and in RFEM. And also important is that all those things are made in such way that the model still is possible to analyze. So there is no problems. The software links to the nodes when I copy and move, and of course there has to be exact modeling, but then it automatically measures those nodes. Yeah? Okay, this was the first model. Next we go a little bit further into the more complicated model, I would say. I'll close this model here and I'll save it on my desktop maybe. Okay, and the next will be, I close this model, close this view. Next will be this model here, which is a little bit more complex, but not too complicated. It has now also surfaces, openings. It has also isolated supports. Okay, what I'm going to do now is I'm going a step ahead. I'm going to show you with the what I can do with the isolated foundation, and I'm going to show you also in RFEM how we can use generators for loads and structure to model the software and then update everything back, model to modify the model and then update it back to Revit. I think it is important to see that, so we understand that it's important to decide where you do the combinations and the model the load generation. Okay, RFEM is, the model is closed. We'll go to Revit and we'll export the model. We'll export the model, again, create a new structure, complete model. I don't have any updates. I'll also use the self-weight, and the first model I'm going to do is I'm creating isolated foundations to surface and elastic foundations, and the same with the wall foundations. Yeah? I start the export, creating a new model, and you see it's here. What happened now is that for each foundation I get a surface with an elastic foundation. This is a simplified model of this isolated foundation. Yeah? So I can work then with the elasticity of that support. We have options to use the module soil in, where you can simulate the soil structure interaction and so on. Yeah? Okay, if I don't do this, I go back to Revit and I'll make the export again, but with the structural setting as they were default, nodal support into line support. Yeah? Start the export, everything is updated, and the elastic is still there because I forgot to do one thing, because I forgot to remove the absent objects, which are those ones. This setting is important because if you work with partial models, you don't want to remove the parts of the objects that you're not exporting currently. So I do this again, and I have to update one more time, and then I hope everything is okay. So now the foundations are removed because they are not found anymore, and can work with simple line support and nodal support. Again, we have dead load in the first load case, and what I would like to point out now is what we have in RFEM, what's not in Revit. We can assign a standard, for example ASC 710, for loads and load combinations, and I can create those combinations automatically. I click OK, and then in the load case table we have the action categories dead, wind, snow. We have actions, dead, wind, snow. We can define the combinations expressions. We get the combinations based on action combinations and the final load combinations with the load factors. Everything just with a few clicks, and everything will be updated as soon as we enter a new load case. So this is, I think, more down to earth and more accurate and more easy to handle than you would do it in Revit for now. Maybe in future Revit has some other options, and then we can also import those. So next is we'll deal with some loading. Let's see if we can analyze this at all. Maybe at this stage it is possible. We have here deformations, so it seems that the model is correct that we imported. But I'm gonna work now a little bit on this first attempt of this building, and we'll create some wind loads and snow loads. I'll select the members by material. So members are all in steel, and I hide everything which is not selected. So I have the plain steel hull basically here. I'm going to apply now, first of all, wind loads. I don't want to do a complete design here because I think that's covered in other webinars. Today we will want to focus a little bit more on this BIM workflow and what is good to do where and why. So I create wind loads, vertical walls and roof according to AICE. You have here automatically access to exposure category if it's enclosed or a partially enclosed building. You have to assign the height of the structure. You can measure it from here to here. You have to assign the base geometry, the roof geometry, and you can assign also the members which are parallel to a certain members. You can just pick here this one, if it's loaded or not loaded, and the load will then be only distributed on the highlighted columns and beams. There's also a little explanatory picture that allows you to understand this dialogue a little bit better. I'm creating now just the wind direction perpendicular to the surface AB. In load case 2, I can do different wind directions at the same generation process. I'll click OK, and the results are given in some statistics. We'll have then the wall pressure leeward and windward and so on. You can check what's really the basis of this load generation. Then we can display the generated load into individual line loads, and also if you don't like what the software did, you can disconnect the generated loads, and you can then delete or change or modify any load you like. Because here is a building, maybe you want to change this. You see in principle how this load generation works, and something like this we don't see in Revit, for example. Next will be the snow load. The snow load can be done also with a snow load generator. I briefly open it here. You have the map, for example, for USA. You can click to the location. You get the basic ground snow load for this location. And in the same way, you have to define the base geometry or the roof geometry and which members you want to load, which load case it goes to. It automatically finds load case category snow. You click OK, and you have then the loads here in your structure. With this, we can step to the combinations and analyze everything. I do not do this now for the surfaces. There are surface loads, line loads, member loads, all you can think of. But I think you have seen the principle how we can generate those things. And one thing I'm going to show also is the load case manager, where we have access to all combinations, and we can say we want this in a first attempt, a geometrical linear analysis. All these settings about the solvers, about what kind of theory we use, stiffness reductions, everything, that's all done in RFEM. So for me, when I have to do a lot of things in RFEM, then I might just do everything as well, according the loads, also the loads, including the loads and combinations in there as well. So, okay, once I have this, I can run my analysis, go there and get my analysis done, combinations done, yeah, and I get also deformations and internal forces. Not enough, as you can see, deflections here are kind of little crazy. I like to change my model. I show you also another option we have in RFEM, how to model things. I select one frame, press Ctrl+C for copy, create a new model. Okay, and press Ctrl+V for insert. I have taken the frame out and put into a new model. Now I can create, for example, a truss. I can pick the left outer node, the right outer node. I can select the type of truss I would like to have. I select the total height, total length, distance from the first span. I can assign the cross sections. I say I want to have beam members everywhere. I click OK, and I have my truss created. In this first approach, I don't want to have any members, any member hinges. I delete them. I can select my truss, Ctrl+C, go back to Revit, to RFEM, to the other model, and I press Ctrl+V, and it will insert my truss into the structure. Ctrl+V again, and I have enter an offset. Okay, and once more, and another offset, which will be minus or plus 20 feet, and we have quickly modeled our truss here. No? Loads and everything else stays the same. No? We have here wind load and our snow load, which shows me that I forgot to enter some self-weight. There's another way how we can do this. There's a tool called generate loads from area loads via plane. We just enter the magnitude. We'll click the roof surface, roof area. We'll say, okay, please do not load my struts, and I click OK, and my load is applied. Maybe at the same time I would like to insert another coupling beam here in the middle. I can drag and drop it to here, drag and drop it to another place, or yeah, actually I don't need it, so I can select it and delete it. Lastly, finally, I will do some bracing here, new bracing, tension member, new cross section, round bar 1, okay, okay, and I'll enter it from here to here. And again, from here to here, from here to here, I can select Control key and left mouse key pressed, and you can drag and drop it from one end to the other. Same with this, Control key, drag and drop here. No? Okay, finally, to conclude it or make it somewhat look like a design, we go to the Steel AIC module, select all members, select the LRFD combination, go to the cross sections, say optimize my cross sections, and I use F8 to copy down from top to bottom, and I can run the analysis, and as a first attempt I get a first approach of the utilization ratio. Of course, I didn't take care now of the buckling lengths and of all the lateral supports. That can be done in that module, but if you're interested in seeing how that works, there's other webinars that can be found in our channel. So now we have cross-sections suggested, and I can export all those cross-sections back into the main model in RFEM, and I have a short optimized model. And this model now I'll send back to Revit. Import model, remove can be stay the same. The loads, the result settings I'll disable now. That will be in the next model. I start the analysis, I start the export. RFEM asks me, hey, you have two models open. Which model you want to use? I use the BIM model. I get my cross-section converted, and pretty soon those cross-sections should show up in Revit. The matching, the linking happens with unique identifiers. So we will we use unique IDs to identify which parts are new and which parts are not new. And of course, you have to obey certain rules when you are working with these exchanges, because if you exchange or if you modify everything in both programs at the same time, it's going to get hard to compare what is new and what is old. So there have to be some rules that have to be obeyed. But for example, we have the joining of the slab and the isolated foundation stays the same. We only really write what is new there. We don't modify any other thing in the Revit model. Okay, this model at the same time, we also said we took a Tekla. I have here Tekla 2017 open. You can also send to Tekla, also direct interface. The buttons are here, direct export to Tekla. It works pretty much the same. You have dialog that allows you to update, to overwrite the models. You can mirror the model if you want to, because some axes may be different, Z-axis down, up, and we export it to Tekla, and when we look at Tekla, the model appears in Tekla. So the engineer who is familiar with Tekla right away has a good approach of my structure that I would like to design, and he can, even so if it doesn't really work with this model, he can look at it, he can double click on it, he can see, okay, this is the material, this is the thickness, this is this type of cross section, and it doesn't have to look at thousands of plans to find out what's the deal. Yeah? Also, you can compare models in Tekla as well. In Revit, there's also options, or there's also tools how to compare different models. Yeah? So we are open to all this, to this world. Okay, this was the second model. Now, next step, I'm gonna go back to Revit. I'm closing this model. I'm opening another model in Revit, which is this time a concrete model. And the next step I'm going to show you is how we can run a workflow. I close this model here. So I start in Scratch with RFEM. I go to Revit. In this file, I also have dead load load case, not extra loads, but just dead load. And this time I use the export calculation import tool. It looks all the same. I'll create a new structure. I'll apply all the loads, and this time I'm importing the results. So this time I'm reading member results, for example, forces and surface results into the result explorer. Displacements and basic forces, moments, shear forces, and so on. I could also, if I have done a concrete design in RFEM, I could also export maps of required reinforcement, like required theoretical reinforcement. And then with this, we could then work in Tekla or in Revit to make the reinforcement detailing. Yeah? Okay, I'll start this workflow. Yeah? Now, the new model is created. It will be calculating model. When we go to RFEM, you see the calculation is running. Yeah? And then after that, we'll import the deformations and the internal forces. Yeah? So we're able to write into the Revit database a set of results. Yeah? And then you can show the results inside of Revit. For this, you must enable the imported categories. And you have to have installed the structural analysis toolkit. And then this button's result explorer will show up. And we can then control with this dialog here which results I would like to see. You know, for example, axial forces of the members. I apply, and we'll get the axial forces here imported with the values. Yeah? Or at the same time, I can say, please show me the displacements. Apply, and you get displacement color maps. Yeah? That you can show. Yeah? And this you can put on your drawings. You also have here a little scale, so I understand what the colors are for. Yeah? So this is a way how you can digitally transfer your calculation results into Revit, and all the other applications who can read the result packages can actually look at this. Yeah? Okay, let me see. Okay. Okay. Yes, this was the workflow. Another thing that can be done is, instead of exporting the entire model, I can export only a part of the model. I don't have to calculate 3D. For example, you can use a section box in Revit, and you just eliminate everything beside a few sets of columns and one story. And you say, please export model, but now only visible objects, yeah, into a new RFEM structure. If I do this, I'll get a part of the model updated or written into a new RFEM file, and I can work here with whatever I want. Yeah? Or if I want just a slab, I just select the slab and I have the slab. Yeah? So I can extract parts of models into submodels into RFEM. Yeah? Again, this model we can send again to Revit, to Tekla. Yeah? So here's this model. I can go from RFEM and I export it to Tekla, and I can either append, so I can make a series of models into Tekla for visualization, or I can override the existing model. Yeah? Okay, I override it, writing the members. You will see, yeah, here the model is updated, and again the engineer in Tekla can understand what he's doing. When we click on a element in Tekla and we acquire the part, then we also have additional information. For example, when there's results, we can see the axial compression, the bending moments. We have also reference to the material in Dlubal, the node, the member. So the member number is 22. So if I look at this column here, the column is here, should be 22, member number 22. I can reference this information and put it on a drawing, for example, inside Tekla. Okay, then finally, I'm going to import a model from Tekla, because in Tekla things are very similar to what we've seen in Revit. I have a model prepared that has also an analytical model inside. Okay, and this model here is steel hall, and in Tekla it looks like this. There is an analysis and design menu, and here you can assign analysis and design models, and I have spent some work to do this. As in Revit, there's also analytical members here, and it has also information like start release, end release. You can set it up here. You can also influence the position, whether it is on the reference axis, on top, bottom. You have more options here. And in the properties of these analysis models, you can either select selected model, or you can filter, for example, the full model, creation model, full model, or select the parts only. So you also have the possibility to export only certain parts, and you choose the Dlubal.net or the Dlubal.net file if you want to get the file. So .net is a direct interface. Once I have this, I can grab this model into RFEM. This time I have to start the import from RFEM. RFEM talks to Tekla, and we'll get the analytical model. If there would be rigid links, which are also possible in Tekla, they would be also imported, and we'll import this Tekla model now. Tekla also has loads that we can import. We also have enabled the basic loads, linear loads, nodal loads are possible. Here there were no loads. I create a simple load case. I have my supports here. I have my cross sections, as you could see. Also the mapping is done with a so-called mapping file, detail setting, cross section mapping. If I look at it, you can see that mapping is possible from the application file name, application section name to the Dlubal name. Yeah, and those files can be set up. It's one-time work depending on the set of sections you want to use, and then you have it in the software. Also the same is for material. Yeah? Okay. Let's see if we can run the analysis, if the model was correct. We can see also there's some hinges that have been assigned, and you can see there has been some results. Looks quite okay. and we can do some changes as well in RFEM and update it to Tekla. Yeah, maybe I can also delete something, delete, change a cross section, create a new one. Maybe let's make a big one. You can see, so we can see the difference. Yeah, like this. Okay, okay, okay. Yeah. And now I'll update my model in Tekla. Update existing model. Click OK. Okay, writing is almost done. So we look to Tekla and we'll see that there is all the changes are there. Yeah. Also note that connections we have designed in Tekla beforehand are not overwritten. Also footings, base plates, yeah, everything is then sent to Tekla and the changes are applied, but things we don't want to change are not changed. Yeah? So, yes, the last thing I would like to show you is what we can do with IFC files. This first model I have imported or exported from Tekla to an IFC file, and in RFEM we can reference this IFC file. For example, if you go to General Data and you'll go to Options, you can enable the so-called CAD BIM model. In this CAD BIM model, which creates a new tab here, down here, you can load IFC or step files. The IFC file that I'm needing is, hang on, is in the Tekla structures models, IFC, out. I open it. And I'll get the IFC file on top of the real file. Yeah? The IFC file can be read here. You have columns. If you click on it, you can see all the details that are written in this column. See, they're swept solid, as I was explaining at the beginning. So when I go here, I can then hide or show individual parts. You know, I can say, please create a member from this IFC file. Create my native RFEM object. Now it's only geometry, it's only visualization. But in order to release the full intelligence, I need to convert it to a real member. You know? And I create this member and I can say, please create it such way that the reference line is in the center, on the top, on the bottom, whatever. Or I can create a surface, or I can create a solid also from this. You know? I run OK, click OK, and I have my member here, and the other column is, well, no, the column was not, it was the beam. The beam is disabled here, it's this one. Yeah? So it was a W6 by 15. I can edit it. Steel is clear, 6 by 15, but it wasn't translated. So I can manually just go ahead 6 by 15 and I can convert it. Yeah? So you can see that there is a little bit more work to be done in the IFC import, or you can, of course, if you set up the IFC file correctly beforehand with the right naming and you are exporting application, then you don't have to manually assign the cross section, but you can import also an IFC file and work with this. And also, because you see both models, you see what is the actually RFEM model and what's the difference in the original model. Yeah? So you can see originally this beam was a little bit lower than it is in the RFEM model because we said the line is on top. Yeah? The insertion line is on top of on the top flange. Okay. If I don't want to see the BIM model, I exclude it. So latest thing I'm going to do is I'm exporting this. Last thing I'm going to do is I'm exporting this to Bentley ISM. Bentley has an ISM file format or database that allows us to write into Bentley applications, and all Bentley applications can read this database. Yeah? So it's also that you want to say it's a direct interface to this application. I click to a new Bentley file, and once it's written, we'll have to go and check out my desktop. Hang on. Desktop. And I have to start the ISM viewer that can be shown. Hang on. I have to display the right screen. Okay. Screen. Monitor 2. Hang on, here we go. Desktop, and I'll open this one. Open. Yeah, and I see the file in the ISM viewer. I should have rotated yet the model, which has not been done yet, but that's possible to set up because the ISM only knows C-axis up. Yeah, but you have all the information also here. I can click on it and read what is here, and there should be somewhere the cross-section designation, material designation, and ISM compatible software can actually read then also from this file. Okay, I think this is it from me. Time is almost over, I think, and I'm done with my presentation, and I would like to ask Amy to take over and speak some final words.
Thanks, Walter. Yeah. So there was quite a bit of information today. I always want to encourage everyone to visit our website, dlubal.com, to find out more about RFEM, our design add-on modules, and even more information on BIM integration. We do have a lot of social media sites. For example, our YouTube channel has all of these previously recorded webinars that you can view at your pleasure. Our email here, if you do have any additional questions in our Philadelphia office, is info-us@dlubal.com. Again, info-us@dlubal.com. Our phone number here is 267-702-2815. We will have plenty more upcoming webinars. We try to do them about once a month. You can find them on our website at dlubal.com under Support and Learning Webinars. As most of you know as well, I try and send a couple of emails to remind you when those upcoming webinars will occur. Many of you are wanting PDH credit for today. That's great. The only request that I have is that you please send me an email with the people in attendance for today's webinar to info-us@dlubal.com. Again, info-us@dlubal.com. Once I receive that email, I will be happy to generate that certificate to you and email it back. And with that said, I want to thank everyone for attending today, and as always, we hope to see you at the next webinar. Thank you.